Hi, this is my Chapter 10 project for Part 2. I picked choice 1. I have the tacks set in at 3 inches from the center each, and I have the string at a reasonable length. So I'm going to start with a marker. I'm just going to go around a few times. And there we have our first ellipse. So now we're going to do our second points. This time we're going to have them at 2 inches each from the center of the ellipse. So we're just gonna set it in one inch each from each point we just used, since the last ones are at 3. So now we're gonna do our second one. And for our next one, we are going to use a red marker. So let's go. Okay, so this one is much more like a circle. It only almost looks like one on here. Okay, so now as you can see, I've added a center for more clarity. We are going to compare the differences of these two ellipses. So this one, the second one is almost like a circle, but we'll see that some of the measurements are different, and we have the center right there. So we can see the A for the first one is almost at 4. The second one is almost at 5, and B for the first one is just about at 2.5 inches. B for the second one is at just under 4.5 inches. So you can see that between the two, this one has the second one has a slightly longer A than B, but it's much closer than in the first one, where it's a much larger difference. And I'm gonna show you how to solve for the first one. Okay, so I measured exactly that the first one had a C equals 3 inches. A for the first one I said was 3.75 inches, and B was at 2.5 inches. Okay, I found that A was actually closer to 3.875. Okay, I made another adjustment. It's actually closer to 2.45. And now our numbers are correct because 3.875 squared minus 2.45 squared equals 9.01. So that is close enough. So now our equation is we have x squared over something plus y squared over, well, x squared over a squared equals plus y squared over b squared equals 1. So now we know a squared, which is 3.875 squared, equals 15.01. We're gonna say that's 15. And y squared, or b squared, which is 2.45 squared equals 6.0025. That is 6. So now we're going to check this equation. X squared, we're going to find the, right here, which is, if y is 0, so that would mean x squared would have to, if y, that means x squared over 15 plus 0 over 6 equals 1. So that means x squared over 15 equals 1. So now, if x squared equals 1, this will be our a. Well, we have radical 15 is about 3.8298, whatever. So that is around 3.875. If you round it, it's 3.873. So that's our a. Now, if x equals 0, which would be our y-intercept. This is our x-intercept. Our y-intercept is right here. So that we want to get to b with that. B as the y value. So, that means we have, if x is 0, so that takes the x squared over 15 equals 0. So then we have y squared over 6 equals 1. So that means radical 6. We're going to find that. Is 2 point, if you round, it's 2.45. Okay, so now we need to identify that b here in this situation is the semi-major axis, also known as the minor axis, and that means it's the y-axis here is the minor semi-major axis because it is the shorter of the lines. B is the shorter of the lines, and so yeah, the also the foci, that's what these are. We've explained that. The eccentricity, we're gonna find that out right now, which is also known as c over A. So, and we know since A is always going to be greater than C in ellipses, this is how we find out what the ellipse is, because if it stays in that range of of greater than 0 and less than 1, then it will be an ellipse. If it is 1, that means I think it's a straight line. So we're gonna see what it is here. It's 3 divided by 3.875. So 3 divided by 3.875 equals 0.77. So C over A, the eccentricity is 0.77, or yeah, it's 0.77 equals the eccentricity. So yeah, that is the end of it. We found how by only changing the distance of the foci, it makes a totally different shape of the ellipse. Yeah, and we found that eccentricity, if it stays between 0 and 1, it will always make an ellipse. And yeah, so hope you enjoyed this. Bye.